Namaskar. Hello everyone. Hopefully you are fine, and today we are going to discuss a very important topic for class 11 students in physics, that is dimensions. So let us be continue with the particular topic. It is under a unit and measurement chapter, on which this dimension is very important. We are having a lot of dimension to understand self, dimension to see the boundary of the wall, dimensions of a particular dice which we are playing. But here in physics, this particular topic has an important role in the dimensions. What dimension is, how it comes in the different physical quantities. So let us be one by one, we will start discussing all this. The symbols for the dimensions of the fundamental quantities. So there are, as we are familiar, there are 7 fundamental quantities and 2 supplementary quantities. So mass, length, time, all these are the basic which we are using continuously. And here on the left hand side you can see the particular term, and on the right hand side the dimension of that term. For length we have written L, mass, M, time, T. In this way, temperature, we write down sometimes theta, sometimes K, current, I or A, both are used. Most of the times we are using A. So dimension is actually the power of the fundamental units of one of the derived physical quantities. Uh, in length, the dimension of L is 1 and the dimension of mass is 0. So that is the power which is raised, which is represented, that particular term, how much time it has to be appeared. So luminous intensity and amount of substance. So these are the 7 fundamental quantities. On the basis of this we study lot of things. For example, by using length and time we can study the speed, where once we get the speed, so we use that particular speed for the another reactions. So in this way it is a chain process. We start understanding the basic fundamentals of these dimensional terms. Let us we continue. What is the dimensional formula? How we write down the dimensional formula of the particular term? Let us try to understand. Before this, already we know the particular term, the formula of that particular term. And so the dimension, when we discuss these dimensions, once we know the dimensional formula, we are familiar with the particular terms. For example, force, we know the units of the force is Newton. We when we know the formula F is equal to ma, so we are familiar with the term, we are familiar with the formula, we are familiar with uh, the SI units of that term. But dimension of that terms is very important. So how to write down the dimensional formula? Let us we see. So dimensional formula of any physical quantity, for example, we write in general form, we can write down. So mlt raised to the power. So raised to the power means here it is the dimension of the particular term. For example, if you are talking about length, so in case of length, the dimension of length is L. So in this way we can write down, and it has a power 1. So here whatever it is, it may be x or y or z, whatever is, suppose here it is y. So these x, y and z are the dimension of these fundamental quantities. That is more important. Now come to the next important part, that is how we write down the dimension of a particular term. So step by step we try to understand this one. This is the very first step. We must know the formula of that particular term. Once we know the formula, we are able to write down the dimension of the term. The second concept is, when we the second step is speed is equal to distance upon time. So write the dimensional formula for the distance and write the dimensional formula for the time. So it is m0 l1 t0. So in terms of m, l and t, we write down the dimensional formula of a particular term. So it is m, l, t0. M, l, for time it is m0 l0 t1. So in the next step you can see this is the dimensional formula. Numerator and denominator, when we club together, it becomes m0 l1 and T minus 1. So this is the dimensional formula. We can also write down this in a particular form, that is LT minus 1. So either we can write down like this, or we can write down M0 L T minus 1. So in both the way, both are correct. We can write down the dimensional formula. So once we do this, yes, we have a confidence, yes, I can. So let us we continue. We try to understand the dimensional formula of temperature gradient. So what is the first step? We know the formula, temperature upon distance. Second step, we write down the dimension of these terms, M0, L0, T0. For temperature it is Kelvin, and for distance it is L. So we write down the dimensional formula of temperature gradient is M0 L from denominator to numerator, L minus 1, T0, K1. So this is the success and the confidence we are getting step by step when we start writing the dimensional formula. So come to the next important point, dimensional equation. Simply dimensional, we on the one side we write down the particular term, on the other sides we write down the equations. So for example, in case of a particular term, we want to write down the dimensional equation. So in case of speed, it is for speed, suppose V is the symbol, this is equal to LT minus 1. So this is the dimensional formula of this particular term, and this is something we will discuss when we come to the application of dimension analysis. That is principle of homogeneity of dimensional formula. That is the terms are to be added or subtracted once the dimensional formula of all the terms are same. So here V is equal to U plus AT if the dimensional formula of the velocity, dimensional formula of the initial velocity, dimensional formula of A into T, if all the three dimensions of these three terms are same, then the equation is dimensionally correct. That is under the application of this dimension analysis. Later we will discuss this one. So this is something related with this particular term. So physical quantities on the basis of the dimensions. So we will discuss four important points. Number one, the dimensional variable. It has a dimension and does not has a fixed value. For example, the force, velocity, acceleration. Force having a dimension MLT minus 2, for example, but it does not has a fixed value. It depends upon the situation. We are applying the force in the direction of the in which the object is moving, or we are applying a force opposite to the, so it is not a fixed value. So it is a dimensional variable. Dimensionless variable, it has no dimension. Dimensionless variable, it has no dimension, and it also not having a fixed value. For example, that is the refractive index, because we are having the refractive index, it changes from medium to medium, although we are using the same formula, speed of light in one to the another medium. So in this way, it is a second important point. The third one is dimensional constant. So in dimensional constant, it has dimension and has a fixed value. For example, Planck constant, gravitational constant. Next is the dimensionless constant. It is also important term. It has no dimension and has a fixed value. So this is important. For example, the constant number which we are using has no dimension and has a fixed value. Let us we give the answer of these questions what we understood till now. A unitless quantity is always a number, right? Maybe a physical constant without dimension, yes, has no dimension. So I think all the above are correct option. It is the correct one. Come to the second one. That is already I have clicked this one. Which of the following is not dimensionless? So density has a mass per unit volume. It has a particular dimension. If you come to this important term, so in density, mass upon volume. So mass we write down m, volume it is L cube. So it becomes ml minus 3. so it has a dimensions. So rest of the angle, arc upon radius, no dimension. So similarly these terms are not having a dimension. So if the next is that if the dimensional formula of the physical quantity is ml2t minus 2, then the physical quantity is, let us see the various options. Yes, impulse is force into time, force per unit area, F upon A, force is F, torque is force into perpendicular, force in perpendicular distance. So torque, force we know mlt minus 2, it becomes mlt minus 1, it becomes ml minus 1 t minus 2, it becomes ml2. So obviously from here we are getting mlt minus 2 into L, so it becomes ml2 t minus 2. So this is the dimensional formula. So the correct option is torque. So in this way we find out the correct option. Next we will continue with another term, that is physical quantities having same dimensional formula. There are so many. Once we know the dimensional formula of the terms, we must start going to the next step. We try to collect a lot of terms one together, and we must have a idea of this one, that is how we can uh, how we can understand the different terms and make all the terms at one platform. For example, there are so many different physical quantities having the same dimensions. So these are some of the important example I am writing here. You can see the impulse and the change in momentum, force, weight, tension, thrust, mlt minus 2, speed, velocity. So these are the terms are having the same dimension. So this particular section is very important. This is a important term here. Angular momentum, angular impulse, Planck constant ml 2 t minus 1. It is ml 2 t minus 1. Angular momentum, Planck constant. Planck constant h is equal to E upon mu. So it becomes ml 2 t minus 2 for energy, for frequency t minus 1. So it becomes ml2 t minus 1. It is plus 2. It is not minus 2. Sorry for the correction. Okay. So in this in the particular term pressure, which I'm writing only those we are familiar. This is force per unit area. This is mlt minus 2 upon L square. So it becomes ml minus 1 t minus 2. In this way we can write down the dimension, we can make a chart, we can make a table, serial number, the physical quantity, the particular formula, and in the last we write down the dimensional formula. These are some other important terms having the same dimensional formula. Angular momentum, and in the previous slide we have seen this. These two terms are having the same dimensional formula. So the force, weight, and energy, also light year, it is a part of this. Let us we try to give a reflection on our understanding. Which physical quantity is similar to the dielectric constant according to the dimensionless? Stress, strain, electric capacity, electric permittivity. Capacity, permittivity, and stress not, because these are the terms having the dimension. Stress is the change in the length or the configuration to the original configuration. So definitely in the part B, that is the strain. Come to the next part. The product of the energy and the moment of inertia has the dimension as that of this is the product of energy. So energy and moment of inertia. So energy we write down ml2 t minus 2, for inertia mass, sorry, mr square. So it becomes m square We can write down the for distance it is L square m square L4 t minus 2, so it becomes ml2 t minus 1 raised to the power 2, and we know that this is the dimensional formula of angular momentum and it is the square, so this is the correct option. So the square of the angular momentum is the right option. Come to the next point, the principle of homogeneity, which I was discussing in the dimensional equation. That is, it states that only the quantities having the same dimension can be added, subtracted, and equated. So, for example, x is equal to y plus z. X is one of the quantity, y is another quantity, z is the another quantity. As we have seen in the formula, v is equal to u plus at. So whatever the dimension of v must be equal to the dimension of u must be equal to the dimension of a into t. In this particular case, if they are dimensionally uh, equal, then these formulas can be valid. Although there is a restriction, the sign may be positive or negative. That is the application of this one. So let us continue. The uses of dimension analysis method. In general, we are using dimension in the three important parts. Number one, very important part, to check the correctness of the formula. Number second, to convert one system of unit into another system of units. And number three, to derive the equations, that is to derive a relation between the different physical quantities. Although it's a very, very important part, and all the three applications are very important. Now, the limitation of dimensional analysis. There are so many limitations, that is why dimensions fail. But whatever the advantage of the dimension that we are using, already we have seen in the three applications. In the upcoming slides, we will discuss these three important in a detail. So these are some of the limitations. Dimensionless quantities cannot be determined by this method. So some of the constant terms like trigonometric, logarithm, exponential functions, dimension again fail to explain these terms. So in case of the physical quantities which depends upon more than three physical quantities, again there is a restriction and dimension cannot explain. Proportionality constant cannot also has a very, very important part we cannot obtain by using this method. If either side of the equation contains addition or subtraction, we cannot use this method to obtain the physical equation. So in this way, we are having some of the limitations, some of the restrictions on the dimension. Numerical number are not having any important. Constant number we cannot give any application. This is a, let us we start one by one application. This is to convert a physical quantity from one system of unit into another system of unit. So in one system, when we suppose we are in SI system and we want to go to in the CGS system, so how we convert? So here is the formula: n2 is equal to n1, you can see m1 upon n2 raised to the power a, l1 upon l2 raised to the power v, t1 upon t2 raised to the power c. So this is l1 is a dimension of the particular term in one system, m1 l1 t1, which is connected with u1, and that is, for example, in SI system. In the right hand side, m2 l2 t2 is on the another way, and this is on the CGS system. So n1 is for example, let us, I will give you example. Suppose we want to convert 1 Newton into how many dyne. So this 1 is n1, this Newton is u1, this unknown term is n2, and this is u2. So our basic purpose is to calculate n2. So n1 here it is 1, u1 is related with SI system, u2 is related with CGS system, and in SI system mass, length and time, it is in kilogram, it is in meter, it is in second, and in CGS mass is in gram, length is in centimeter, and time is in second. So in this way we use this formula. Let us see in one of the application. that is convert, for example, 1 joule into arc. As we know that 1 joule is equal to 10 raised to the power minus 7 arc, but how it comes? The first important point is joule is the unit of energy, and this is the dimensional formula of the energy, ml2 t minus 2. So from here we calculate the value of a, b and c, which we are putting on the power of that particular term, because it is very important. If we don't know the dimensional formula, we cannot proceed further. So the first step for everyone is that remember, practice, try to go through the different formulas, and then we are able to write down the dimensions, and once we know the dimension, then the application has to be done. So in SI system and CGS system, mass, length, time is in second, mass is in kilogram, length is in meter, and N1 is 1. And in the CGS system, mass is in gram, length is in centimeter, time is in second, N2 that is unknown to us. So use that formula, N2 is equal to, and in this way we can find out, and this is m1 upon m2, this is m1 upon m2, L1 upon L2, T1 upon T2. So now these are the three zeros, 3 and square, it becomes 4. So ultimately multiply by 1. So in substituting the value of this N1 is equal to 1 joule. So when we substitute this 1, so 10 is to the 3, 4, it becomes 10 is to the power 7. So 1 joule is equal to 10 is to the power 7 arc. How smartly the dimensions help us to convert from one system of unit into another system of unit. Come to the next to check the correctness of the given physical quantity. Already we have discussed. Let us consider one of the important point. If the dimension of this particular term S, dimension of ut, dimension of half a t square, here is again the drawback of the dimension. These half, it's a numerical number, has no importance. So dimension of these physical quantity, if the dimension of these three are equal, it means the formula is dimensionally correct. S is for the length, ut, that is a u for the velocity, t for the time. So lt minus 1 and t l half a t square, for a lt minus 2 t square, again l. So obviously l it means in general we can say it is l is equal to l plus l. So it is a dimensionally correct formula. So all the three terms having the same dimension, and hence the formula is dimensionally correct. Come to the next important part, that is the third application, to derive the relation between different physical quantities. So different physical quantities, let us consider the time period of the pendulum depends upon three important terms. Number one, the mass of the bob. Number second, the length of the pendulum. Number three, the acceleration due to gravity. So this is the problem, and the question is derive the expression dimensionally. So the first step is write down in this way: m raised to the power a, l raised to the power b, g raised to the power c. So m, l, g are the symbols for these terms: mass, length, and the acceleration, and t is for the this particular time period of the oscillation. Remove the proportionality sign and put the constant term here, we get equation number 1. Now the questions will be continued only if we know the dimension of the term, otherwise we will stop it. In any of the relation, if we don't know the dimension of any of the term, we are not able to further proceed from here. So let us case the dimensionless constant, and substituting the dimensions of the various quantities, we get on the left hand side only t, so m0, l0, t1. On the right hand side there is no need to go with the k, m raised to the power a, l raised to the power b, g is for acceleration, it is lt minus 2 raised to the power c. Now the next step is very important, equating the powers of m, l and t on both the sides. So before proceeding, we make all the terms together: m raised to the power a on the right hand side, l raised to the power b plus c. I think it is clear. If the it is in multiplication form, so power to be added like that in the logarithm. You can, for remembering, you can do like this. minus 2 into c, just like equations, minus 2c. So 0 is equal to a, 0 is equal to b plus c, and 1 is equal to minus 2c. So when we compare all these terms, the powers on both the sides, and from these we calculate the value of a, b and c. So a is 0, very clear, c is minus 1 by 2, and if c is minus 1 by 2, so b is equal to plus 1 by 2. So solving all these, we are getting the value of a, b and c. Substituting all these values in the given equation, and we get k m raised to the power 0, l raised to the power 1 by 2, g raised to the power minus 1 by 2. Minus 1 by 2 denominator, d 1 by 2 numerator, 1 by 2, so under root k as it is, m raised to the power 0 means 1. So we are getting t is equal to k under root L upon z. So although it is a correct formula, but from experiment, if required, we can, if we know, we can write down the value of the constant. Let us we understand about the reflections, about what we have understood till now. So these are the four options, that is dimension analysis method can be used to check the correctness, yes, to convert one system into another, yes, to derive the equations of different physical quantity, yes, all are correct options. So come to the next one. The quantities which are added or subtracted or equated in a physical equation should have the same dimension. This is known as, yes, it's very well familiar, it's principle of homogeneity. So this is the correct option. So I think we have discussed something about the concept of the dimensions, its applications, its important phase. So thank you very much for watching this particular concept of dimension. We will continue with the so many further more terms. Till then, goodbye. See you.